Welcome to the February meetup of the Temporal community. This is the monthly regular meetup that we always do on the fourth Tuesday or last Tuesday of every month. And of course, the long-term vision is that this is going to be one of many meetups. This just happens to be the one that we host. But if you're interested in hosting your own meetup, let us know and we'll help you organize it. I think there's some interest in the Temporal Slack to run a London meetup. So whoever is in London, if you want to start something, we'd be happy to help you promote it and get people there, even though we physically cannot attend. And we also help to provide materials and prep and anything that you may need to run your meetup. But all right, so you're here for the flagship meetup. So we'll cover a typical agenda that we have which is temporal news. Then we'll have 3 speakers. Thank you so much for the speakers who've graciously volunteered to share their time with us and also get their work in front of the broader temporal community, which I am very excited about, especially because I've seen some previews of everything that's about to happen here. Just to catch people up, for those who have not seen what happened last week, a lot happened. I'm still recovering from it. So I always like to feature the work first. So we're going to talk about temporal open source. Temporal 115 did not ship last week, but I think we started telling people about it last week. There's still some things that we have to work out for M1 Max, but V115 is out and you should upgrade to it. Sorry about that Slack message. Let me make sure that I don't have Slack running on my own machine. Okay, so the 2 main features that we want to tell people about, obviously there's always bug fixes and stuff. The 2 main features we want to tell people about is that Temporal can now run as a single binary using SQLite. And the command that you should check out is temporal server zone SQLite start. For more details, of course, check out the PR that I actually merged this in if you want to read the code. Surprisingly accessible, but of course, this doesn't include all the work that went before in the prior 4 or 5 months into preparing the SQLite driver, and of course, which has been picked up and helped along a lot by the Temporal Lite work done by Jacob Legrone from Datadog. The second feature that we should tell people about is that cron is now on v3.0, which is essentially the underlying dependency that we use to do cron workflows, has now been updated. And now we support time zones. There are a bunch of other things that we also support, but that is the headline feature. We've also updated the docs accordingly. So you might want to check that out if you care about time zones. There are also some nuances. So please, please, please read the docs carefully before you make your upgrades. 2 other things, one more thing I wanted to note about both of these features is that they're by external contributors, which is something that I really want to highlight and something I love about Temporal, which is that the server itself is open source. If you feel like there's something that you really want to contribute, both our headline features for this version are open external contributions, which is amazing. So really highly encourage that, and of course, try to check in with us before you do significant work, because it may not align with the project goals, or you may need some guidance that we can give. So thank you so much to Wolfie and LB3K. I don't actually know who that is, but thank you so much to the people who contributed to that. Okay, of course, the headline news for last week was our Series B. A lot of you here probably attended our live stream. We also published a couple of blog posts related to that, all of which can be found under temporal.io/b. If you want to find out more, I won't bludgeon you over the head with those details, but thank you so much for supporting us in this journey, and we're only getting started. Finally, in conjunction with our Series B, we are realizing that a lot of people are new to Temporal, coming to us for the first time. And a lot of you are Temporal fans, but have coworkers that you would like to bring into the fold. So we're doing a series of live sessions, so you can ask all your questions live. We've been starting that since last week, but this week we're going to be continuing with pretty much 2 sessions a day until the end of the week. So if you're interested in particularly the sessions with Java, Golang, TypeScript, architecture, and there's a special one on Friday, which is more on the business use case side of Temporal. I highly recommend that because this is the only time that you'll get our heads of product to talk about product stuff, or essentially the product executives talking about product stuff, which is really awesome. Okay, so I think that's it for temporal news, and now we're going to segue in smoothly into Checkr. Itay and Maria, are you there? I saw you guys in the.
Hey.
Yes. Yeah. Hey, how's it going? Okay, awesome. I'm going to stop sharing, and you can take over. But essentially, Itay and Maria, we've been preparing this learning paths, and Checkr has been on our landing page since forever. So this is the first time I'm really excited to have Itay and Maria to present about their temporal journey. Also, another thing to note is that they started with Cadence, and so they're one of the rare few examples where they've actually had to migrate their production workflows from Cadence to Temporal. So there's a unique story here. So Itay, Maria, take it away.
Thanks. I guess everybody can hear me?
Yep, you're coming over great.
Awesome. Okay, awesome. So hi, my name is Itay, and I'm here with Maria, and we are going to talk about Temporal in Checkr. Okay, so as I said, I'm Itay, I'm a senior software engineer, and Maria is a staff software engineer in Checkr. And this is how what we're going to talk. We're going to see how a background check unfolds, what are the challenges, how we are using Temporal, some use cases, future plans. Hopefully it will be fun. So first, what does Checkr do? Checkr does background checks. Background checks are the process that someone needs to go before they can go into and work, let's say, for Uber or Lyft or whatever company. They need to make sure that the person can actually work for them. So a background check starts with a collection of PII, which means private identified information, like let's say social security numbers, addresses, phone, all this stuff. It runs screenings based on this data by using external vendors, that they give them some of the PII and then return us the result of the screening. For example, for MVR record, motor vehicle record, to see if there are any citations for the person that we're running the screening on. And we produce a report. A report is essentially a list of screening results. So that's the base, really base terms that you need to understand in order to know what Checkr does. And okay, so this is kind of how we used to do it, a little bit of how we used to do now. You can see that it's a bit look like messed up. There are really like bespoke state machines and various weird definitions and processes for each check, and each screening can actually reach out to the internal details of other screenings. This is actually natural and happens in every company that starts and then grows big, because initially you're just going for the wins. You're doing the stuff that is the most faster to do in order to get the better bang of the buck, so you can continue living. And then when you have one success, now you're mired in technical debt and you need to eat your own spaghetti or dog food. So this is stuff that we've been trying to solve for a long time. The challenge is that we have inefficient product development due to tech debt. Now that everything is such a spaghetti, it's really hard to reason about and to know how to implement new stuff without breaking old stuff. There is no crisp model for how skin behaves, not enough separation of concerns. Complex scenarios are really hard to deal with because there are a lot of nuances that the background check needs to comply with. And basically lack of formal definition and pool boundaries lead to lack of clarity, which I think we can sympathize with that. That leaves us looking like this. This is very cute, but this is not fun. So we needed changes. So faster time to value, we needed to define, and that's the most important thing, I think, crisp interfaces between components. We need to be able to compose different orders, like different ways we run screenings on the fly based on customer demand. And we needed to have a compliant storage for data that we gather, like PII and screening results. We needed better tooling and much easier way to test it. So this is the model that we moved to. You see that it's much less spaghettified and it's more layered. And Zoom bothers me in a moment. That's it. And what we are doing essentially, we have actually we're moving to the layers model. So we have external vendors. We have screenings that. Wait, let's use the. Where is it? Where is the laser toy? Oh, there you go. Now that's better. We have external vendors. We have screenings that talk to the external vendors. And we have some new model that we call screening orchestration that knows which screenings to call at what order. Sometimes screenings depend on other screening, for example. Other than that, we have something that we less focus on, which is the order lifecycle, and then we talk to the customers. So we introduced Tasker. Tasker is the name of the execution mechanism that we are using in order to coordinate the screenings. We really like the letter R. We have a lot of components that have the letter R at the end, like Flagger and Tasker and Checkr. It kind of makes us sound like pirates. So what is Tasker? Tasker is a screening orchestration system. Tasker defines a strict task interface, which is the thing we needed the most. The task received facts and meet facts and operates based on some kind of configuration. Only data with schema, for example, a fact defined as a protobuf, can be given and received from a task. No arbitrary JSON flying around willy-nilly and stuff like that. So this is essentially how we model a task. How do we execute a task? So let's say we've got some kind of order and we want to run a screening. A screening is abstracted as a task. So what we do, we create some input facts. Facts are actually the atomic pieces of data that we're using and storing in our system that we can refer to later. Let's take a sip here. So we're storing the fact. After that, we're creating something that's called for our records a task record. A task record says, hey, we are having this task going to run. Let's keep an eye on it. Once the task record is created, we are using the Tasker service, and we're using this thing called Temporal, I believe you heard about it, to actually start the task worker. So a task is actually a temporal workflow and activities, but let's begin with the workflow. Once the workflow starts, it actually fetches the facts from the fact store and the task from the task store service and do its stuff. When it's done, it writes the data that the fact that it produces, mentioned in the task store, and updates with a Kafka message to the order in order that to run. Essentially, you don't need to understand all this to understand Checkr. Essentially, we abstract screenings as Tasker workflows. That's the main thing. Okay. Yeah. So we're essentially using Temporal as the execution mechanism that is abstracted by Tasker. Tasker is also an abstraction layer above task execution. Task execution is delegated to Temporal. Essentially, Tasker tailors Temporal to Checkr's need. We have another layer of interface, which we call Tasker, that adapts Temporal API to Checkr's API that is more convenient to people who develop new screenings and stuff like that to develop them. Each task is implemented either as a workflow and activity. The only data that is allowed to be shared with a task are facts and configuration. This is enforced using temporal data converters. Now, temporal data converters are awesome. They enable us, and you'll see it in the demo later that Maria will show, to not supply any actual PII to temporal. Temporal never holds any information from Checkr other than pointers to facts and tasks. The Checkr will tell temporal, hey, this is the task ID, start the task, start the workflow about this, and when the workflow begins, it consumes the facts used by facts ID. We are using actually the data converter to convert between actual facts data and fact ID and the other way around. This is very useful if you haven't used data converters. So temporal server never see, as I said, actual encrypted data from Checkr. All PII is stored as facts, stored in a compliance store based on GDPR. I need to read this sentence. Each fact is stored in a key value content addressable store and have an associated fact ID. When temporal receives the request to start a workflow or an activity, only fact IDs are supplied. The data converters know how to acquire the real facts from the fact store using these IDs. This is how facts actually look like in our system. When we want actually to start to create a new fact that goes into the system, it must be defined in protobuf ahead of time. It's also because it's cross-claim compliant. We're using both Go and Ruby in Checkr, and everything is strictly defined up until what we can do. There are another layer of verification later, but that's the base idea. This is an example of when you're looking at the Temporal UI, you can see that it doesn't receive any actual information. It receives the task ID and returns the fact ID. Temporal never sees anything concrete other than these pointers, which is awesome. So in Checkr, we have another thing that is kind of unique. I think we have two kinds of workflows. We have static and dynamic workflows. When running a specific screening, we know all the steps. Let's say when we're running a specific screening, we know ahead of time all the steps that need to be taken before the process even begins. For example, a common screening looks like this. We prepare some kind of data based on input facts, send it to the vendor, wait for a response from the vendor, annotate the data, and send the facts back to the order. Always the same flow. The workflow will always be the same. You could draw it out like a flow chart if you want to. A dynamic workflow, on the other end, is what happened in the screening orchestration. You can see the screening session as a dynamic workflow. We do not know ahead of time which exact screening are we going to run. For example, after we run SSN trace based on SSN number, we get a list of addresses. That's what SSN trace gives us. We only then know which states to run, let's say state criminal search on, or other reports that might be other screening that might be needed. So we needed a way to do it dynamically, and temporal actually gives us the best way to do it because we don't just go and draw the flow chart. We actually have some code that if any crash occurs can be even replayed in order to decide stuff on the fly and choose the next step. This is quite unique and we actually love this. Before we embarked on this adventure, we did some experimentation and modeling. So this is an ugly chart using dot format, using dotty that can show, for example, that you don't need to understand all of this, but see the highly dynamic nature of our process, that we start with some kind of social security number, we're running some kind of SSN trace. We got SSN trace results, various facts, and based on the facts, we know to run, let's say, state criminal search, county criminal search, and stuff like that. Even when we don't have, let's say, in New Jersey, in Bergen County, we know something goes there, but we don't know exactly what, the workflow can decide, okay, run a county search on this county that we haven't done in the first place, and then we discover some, let's say, someone committed, let's say, a murder in Bergen County with this social security number. So that's very useful to have this kind of ability. Another special thing that I think not everybody undergone with temporal is that we actually started with cadence. When we started Tasker, temporal was probably just a fever dream in Max's mind. Only cadence was available, so we used that. When temporal came to be, we already had a long-running task in production and we couldn't just make the switch. Let's say for international, with long-running queries that can take months even, which is not that unusual. We couldn't just take it down and move to temporal and restart it. We had to keep this running. The way we did this, we started in each screening service, we had only cadence worker. What we did, we actually now start both temporal and cadence workers in each screening. in a way that old workflow can still run with the same code or even new code that I'll show how, and the temporal worker can actually take all new workflows. So the same exact code is running both for Cadence and temporal. How do we do that? Since we're using Tasker, we actually introduced another layer called Temporal Compat. What we did is actually we expose everything as in Temporal API using a Temporal SDK. Old workflows that were coded for Cadence moved to use the Temporal SDK, but what we did, we actually passed them a cadence context with the custom of the temporal context. That way, when they actually access anything that needs to use cadence, we actually move them to use temporal behind the scenes. Sorry, the other way around. If something coded that looks at temporal, but it's actually a long-running workflow with cadence implementation, we actually use the cadence SDK. It's a bit confusing, but it works great. So, for example, execute local activity, because we are using this temporal compat compatibility layer. By the way, if anyone is interested to use such a thing, let me know. I might share the code. We do execute local activity, and if the actual context is actually a cadence context, we're actually using cadence to actually execute the local activity and return this as a temporal future, and it works great. For example, in a workflow handler, we actually calling a Tasker temporal workflow, this abstraction temporal. This will call tcompat under that, and will actually launch either cadence or temporal based on on the context that is given here. This is quite cool. So we really love temporal. Thank you, temporal. This is awesome. Temporal hosts and manages temporal for us. So far, it's been pretty smooth. I see Ryland is smiling, which is awesome. He should smile. He has a lot of good reason to smile. And we are getting quick support. And yeah, awesome. Thank you.
We love you too, Itay. We love Checkr in general.
Yes. Let's hug.
Yeah, thank you, Itay.
Okay.
Yeah, so I'm Maria. I'm on the Checkr's international team. So I would like to share some insights on how international screening works at Checkr using Temporal. So yeah, as previously mentioned by Itay, running a background check is this multi-step process, and most of these steps can be easily visualized as like separate workflows defined across our ecosystem. But before that, before explaining how an international screening is defined at a very high level, I would like to share some insights on the current state of our platform. So next slide, please. Yeah. So our services are deployed in 2 different environments, US and, staging and production, and in 2 different regions, US and EU. Temporal is also hosted in 2 different regions for us, and this is mainly required for data privacy regulations that we need to comply, depending on the candidates that we're running the background checks for. So far we have defined 10 different workflows across different products, and we have defined a few common activities that are also used around different products. We have around 30,000 workflows executed in production at this moment in the past year and a half. And yep, we can go to the next slide, please. So yeah, all screenings at Checkr, not only international ones, can be now defined as a group of activities that are required to complete an investigation process, right? Let's say we're performing an international criminal search in the UK for John Doe. So as the input of this workflow, we're expecting candidates' personal information, and as an output, we expect records or no records. So it would depend on the type of search that we're running. We can be running criminal, education, employment searches, and depending on the type of search, we're going to expect criminal records, education, or yeah. These activities are meant to complete one specific step of the process with a well-defined input and output. So for example, if we take the first activity, which is going to be like create an order for the data vendor. this is going to be its own activity. As an input, we're going to have the candidate data that we need to send out to the vendor. And as an output, we expect always to be a vendor order ID that they created, so we can then externally refer to that order using that ID. So yeah, this activity in our case will definitely block the entire process of completing the screening and the background check. And this could take seconds, days, weeks, even months, depending on the search and the country that we're searching on. But yeah, once at this point, we just need to pause the workflow and wait for the data vendor to send us webhooks to notify us that they complete the order. So once we have this, we will resume the workflow. We'll start parsing the information that we got from them and notify different services in Checkr about screening completion. So sometimes it would be reaching out to internal teams for review, or notifying a screening completion to the customers or the report orchestration level. And also, for example, send billing information so we can now invoice the customer for these searches that we're running. Yeah, next slide, please. So yeah, at Checkr, we have implemented this customized UI for engineers to access workflow information. And this UI interacts directly with our Tasker platform. This is very useful for us. We can see the task ID, which we use as a reference across different services. We can also see the metadata, some logs. We can link each task to the executors page, which was previously Cadence, and now it's Temporal. So then we can see the details on the Temporal side about each workflow and activity that we're executing under this task. But yeah, this is pretty helpful for us. If you see the task log records, we definitely check out like every single step of the process, and we can link into the activities themselves. So we can take an insight into the input, into the output of the activity, and make sure that things are, make sure that things are well defined and the task is behaving as it is expected. So if we click on a child task link, which is the little red circle, in the next slide, we're going to see how the activity page will look like. So if we can go to next slide. Thank you. So yeah, this is the way an activity looks for us. It's the same structure. We're going to see the input, the output. The task configuration will determine how this activity will behave. And this UI, it's mainly used for developers at the moment, but we plan to revisit its purpose in the future. So to see if we can extend this usage to other teams, internal teams at Checkr, mostly on the operations side. But yeah, just wanted to highlight that having this visibility to our workflow is pretty helpful for us. Next slide, please. Yeah, when it comes to celebrating our wins and our learnings, we definitely need to call out that we get multiple things when developing our products using Tasker with Temporal. So developer experience has been revamped when defining workflows across the platform. I think we believe that modeling our problems as temporal workflows have definitely helped to simplify our thinking process and development processes as well, and has also provided the workflow observability that we were previously missing. Before temporal workflows, like it was pretty hard. It took us a lot of engineering effort to understand how things were failing, how we were able to move things forward, because there was no visibility of these challenges at all. So this has definitely helped us. And of course, this transparency makes the debugging process easier for engineers. So as mentioned before, the activities required to run screening workflows are very similar for all different products at Checkr. So as a best practice, we have created this shared package that implements common activities and can now be included as part of any workflow defined with Tasker using Temporal. So activities like sending billing information, notifying other teams, or communication across services. So these interfaces are pretty clear now and are able to be shared across different teams and products, which is awesome. So yeah, this has been a great collaboration opportunity for us in the organization and has certainly improved the engineering productivity. So that said, if we go to the next slide. Thank you. We want to expand temporal usage for new teams to build new products. We also want to redesign that code that we developed a few years ago and moved out core workflows at Checkr to use Temporal now. Also encourage the creation and adoption of common workflows and activities, as well as extend the functionality that we have in our UI to enable engineering efficiency. So overall, our journey with Temporal and our Tasker wrapper that Itay went through has been great. It certainly facilitates the thinking process when it comes to implementing complex scenarios, using long-running and reliable workflows. And at the same time, it gives us the visibility that we were missing for some time. So it's definitely easier to know what's going on with our workflows and get some insights on it. So I think this is it. So thank you so much for your time. We would love to hear questions, comments, reactions, and yeah, we're hiring. So I think the next page. Yeah, if you want to reach out to Itay or myself, we also have a link to the engineering page at Checkr, where you can find links to our blog post, the open roles. So yeah, it will be great to hear from you guys. Thank you.
Woo! I would do my clap track, but I'm not sure if I'm sharing the sound on Zoom. Thank you so much, Itay and Maria. That was an awesome presentation. And I believe we have some questions, a couple questions, one from Rob and then one from Rahul. Rob, if you're ready, we've been basically working on a learning path with you and trying to figure out how best to teach people some of the intricacies. So Rob, take it away. Rob, are you there?
What's the question?
Yeah,
sorry.
good. Rob, are you there?
He isn't. His mic is unmuted, but for some reason, I don't think.
Yeah, his mic is not connected. Hey, Rob.
We can hear you.
Okay, cool. So I was interested to know if you've had any problems with workflow task timeouts as temporal users, because I know there's been a lot of confusion about how this affects running workflows.
That's a pretty broad question, I think. I mean, do you have a specific example? What do you mean?
So I know that we've often found that workflows can struggle to make progress when they're a lot of people have seen workflow task timeouts occur in the UI when they're debugging workflows. Sorry, stuttering. And I was just wondering if you've had a lot of problem with that, or if it's caused you any confusion when you've been running workflows. If it's clear to you that the workflows don't fail.
So I'm not clear, but you're saying when debugging workflow, you mean in debugger or some kind of logs? Because I know when you debug workflow where temporal can get like cranky and tell you, oh, the workflow is in the DEG log, oh my God, and panic on you, which, you know, and then debugging is slightly difficult using a proper debugger, but you don't always need a proper debugger to actually debug workflows. On the other hand, if you're talking about very long running workflows, and when you debug the workflow and the timeout need to be big, so we're using big timeouts for that. Essentially, the way you use timeout is like you have explicit timeouts, like we have something called Pennsylvania child abuse screening, okay? And there a workflow can take for a month. So we create our own timeout to wait inside the screening, explicit timeout, and wait for it with a select. And for that, this is something that we use in order to know, oh, the user hasn't uploaded any document in a month. Let's tell them, oh my God, something is wrong here. And there is also the temporal level timeout that we're using only if something seriously wrong. Let's say we got some kind of bug and we have a workflow that lingers for a very long time. We need to, let's say, garbage collect and alert about this in the developer level. So that's how we use the temporal timeouts. So I don't know if this answers your question.
Yeah, that makes a lot of sense. Thank you.
Okay, Rahul, we have one more question for Rahul who wanted to ask it live. If you're
hey guys, can you hear me?
Yep.
Yeah.
Yep. You're good.
Thanks, Itay and Maria, for doing this. So I'm from Confluent. We're in the process of doing something very similar. I wanted to ask you guys if you have any learnings to share about two things. One is when you're trying to deploy in production, are you guys doing it cross-Checkr, or is it different teams in Checkr doing their own thing?
Maria, do you want to take it?
You mean specific to temporal servers? Because we do temporal hosts temporal for us. We do not deploy them here.
Okay, got it. And the second thing is that did you have any pushback on using temporal cloud?
Do you want to answer that one, Itay?
So I'm not really sure again what the question is. I mean,
so
we deploy a Checkr, like each team deploys their own the services. So it's not that we deploy the entire temporal, all the workflows together. Like International deploys their temporal workflows, which we call Tasker again, and let's say MVR team deploys their own stuff. That's what is that what you asked?
Yes. So so we are planning to self-host temporal.
Okay.
So that's why we need to make that decision whether we want to do it cross Confluent or each team does its own thing.
So if you're deploying your own host, I'm guessing you're talking about not the temporal itself being deployed. You're talking about the services, or you're asking about the temporal itself?
Temporal server.
I think he's asking about a multi-tenant versus like a single tenant deployment structure where you have teams that each have their own cluster of temporal server,
right.
and then you do tenancy through that. Is that correct?
That is correct. That's exactly what I'm asking. So do you guys have any decisions to make around those? And I guess you guys just have a single tenant.
Yeah.
And okay. Makes sense.
Yeah, we're just using we used to have a single tenant, like a single temporal server, and that's it. And we just move it to temporal, and they do it for us, which is awesome.
Before, when we were using Cadence, it was just one across Checkr team. So we didn't deploy multiple ones.
So I don't want to hog all the questions. Just want to sneak in one more thing. So do you guys have any additional business logic on top of your activities? Like, do you guys guarantee idempotency, or do you have anything else that you build on top of your existing workflows?
Yeah, definitely. So each workflow will depend on outputs of activities. So we rely on those. Our business logic rely on those outputs of activities and workflows.
Got it. Thank you.
Rahul, you should definitely reach out to. There's a lot of nuance in that first question. We'd be happy to help you there.
Sounds good. Thanks,
Sounds very good. All right, we have a couple more questions in the Zoom chat. So if you, Itay and Maria, if you want to take a look at those, we should answer them async. But otherwise, thank you so much. And thank you for a wonderful presentation. And people should check out engineering.checkr.com for joining the Checkr team. Thank you so much. All right, so we're gonna move right along to.
Let me stop presenting.
Yes. I see someone's using the clap feature on Zoom. I actually don't know where to clap on Zoom, but somehow there's reactions. Of course, I'm gonna put a clap there too. Okay, so Fran is up next. He's the co-founder, CEO, boss person of the AsyncAPI movement. Fran, are you there?
Hey, Sean.
Can hear some sound. Yes.
Thanks for the invitation. You hear me well, right? I was in the app. Okay,
no,
perfect.
You're good. All right, take it away.
Cool, thanks. So thanks again for the invitation. My name is Fran Mendez. I am the director of AsyncAPI Initiative, and also work as director of engineering at Postman currently, where I work full-time on AsyncAPI. So what is AsyncAPI? That's what I want to introduce in this talk. This is going to be a brief talk, most probably around 10 minutes. So I'm not going to be extending so much. I'm happy to help after the talk. Anyone and whoever has questions, I'm happy to help. So, and also on our Slack channel. Cool, let's move on. So as I was saying, what it says in KPIs, I think to answer this question, we first have to introduce a few basic concepts, and especially the one about event-driven microservices or event-driven architectures, usually presented as microservices, but not necessarily. So yeah, this diagram that you're seeing here is a really simplistic representation of a basic event-driven architecture. You have a REST API pushing a message to a broker, that circle in the middle. And that broker can be Kafka, like we have Confluent here in the call, so it's a good example. Then other people, other services and other teams can be subscribing to these messages, like email service or Slack notifications, and you want to react to these messages and then push a notification to Slack, right? So I think that's like the very minimum you need to understand from an event-driven architecture perspective. But that's not just that. Like another common use case for event-driven architectures is the IoT use case, right? So what I mean by IoT is actually not so much in the structure. As you can see, the diagram is exactly the same. Nothing changes. So you have messages flowing around through a broker in the middle, but the use case is different. In this case, is for sensors, like in this case, street lights turning on and off, or dimming the light, and a control panel controlling things in and out. So yeah. And another one that I wanted to mention is I would say the basic streaming APIs, not to be confused with streaming like Kafka, for instance, like Kafka streaming, but more like HTTP streaming, the good old HTTP streaming, right, which has been around for a while. And I like to present an example here, which is the Twitter streaming API. And I find it funny because Twitter closed this API a few years ago. And it's a pity because you could subscribe to tweets real time. So you could receive these tweets real time using HTTP, not HTTP 2, HTTP 1.1. So that was really cool. And it's still in use by many companies, and with HTTP 2 even more. So yeah, to summarize, we have this type of architectures, event-driven architectures, which are basically like in essence, what an event-driven architecture is a type of architecture where events are flowing around the services in the architecture, right? Usually through a broker, but not necessarily. Cool. So so for that, there is a problem was presented in the past, right? So I'm sure that you're familiar, some of you are familiar with Swagger or OpenAPI. I have some friends who will kill me if I keep saying Swagger, but that's the reality. It's still around. So yeah. And these specifications are meant to describe APIs, REST APIs in this case, or HTTP APIs if you want. But for those event-driven architectures, there were nothing. Like how do you describe in a machine-readable way what a service is doing? Like, is it publishing a message to a broker? Is it subscribing to a specific topic or to a specific channel, call it whatever you want? What is it doing? Like, how are things connected? And also answering questions like, if I change this message that I'm publishing to the broker in this specific topic, who's going to get affected? Like, who's really going to receive the message? So I can ping those teams and say, hey, I'm going to change the message. So you please have to update your code before I break something, right? It is, well, in essence, it's almost impossible once you are a big company. It's almost impossible to discover these things. So yeah, that was the main reason I wanted to create the AsyncAPI specification. If I'm not mistaken, it's like this year is going to be 6 year old. So yeah, it was mainly for me to have documentation, for me and my team, of course, to have documentation about what the service is doing and what others can do with my code, with my services, with my events that I'm publishing, right? So yeah, and it can describe pretty much anything, like any kind of event or yeah, message-based system, if you want, like I described before, right? So AsyncAPI is, like I said, it's a specification for describing event-driven architectures. It is protocol agnostic though, so it's not just for Kafka or not only for AsyncAPI. We support literally any protocol. Of course, some protocols are more established and more famous, if you want. So they have better support in terms of tooling. But yeah, like we don't restrict from a specification point of view to a specific protocol. So yeah, that doesn't mean that you cannot add any specific information about your protocol or interesting information about the protocol in your messages. You still can. We provide a way to do so, and so yeah, you're covered. Want to show a quick example, if you want, of an AsyncAPI specification file. In this case, as you can see, there's a YAML file. It has info, servers, channels, components. So servers are usually brokers, but not necessarily. Can be WebSocket servers, for instance. Channels are what usually people call topics in different protocols, and components we'll see later what it is. But I can already tell you it's to reuse stuff inside the spec, so you don't duplicate information. So in your info object, you can specify stuff like the title of your service or your application, the version, description, how to contact the author, the license, if you want to expose it to the public. Yeah, common stuff. Servers, like I said, mostly brokers. So in this example, I'm showing how you could use MQTT with Mosquito or MQTT with your own broker in your company, or or same thing the same way I'm using MQTT in this example, you could be using any other protocol. And yeah, this is just to define and say like, hey, there's a broker here. It speaks MQTT, and if you want to receive messages or publish messages, you'll have to connect here in this URL, right? And you have to provide user password because security says that you need to provide user password. Or if you're in production, you can also provide a X509 certificate. So like I said, like channels are what's usually known as topics. It's the place where the messages are flowing in an event-driven architecture. And so you can define them all there. Like you can have a summary and description, like defining like what this channel is about, what operations you can do, like can you subscribe, can you publish? If so, what's the message that I can publish here, or what's the message that I will receive if I subscribe? By message, you can have information like headers and payload, all sorts of types of information. This information is defined by JSON schema, not AsyncAPI itself. So, so yeah, if you already have something for OpenAPI defined, you can reuse it here. Or if you already have your schemas defined with raw JSON schema, or you have them on a schema registry, then you can reuse it here. So yeah, it's all about reuse in the end, and defining the interactions of your event-driven architecture or your event-driven API if you want. In this example, I'm using JSON schema, but we also support Avro or RAML payloads, and we're investigating for version 3 to start supporting other formats like GraphQL schemas, or like protobuf and gRPC. I think it's not really gRPC, it's protobuf. So yeah, protobuf in the end. And briefly, like components is there are a bunch of things that you can define in your AsyncAPI file. In many situations, you'll find that you repeat it yourself a lot. So we provide a components section on the file that where you can put reusable chunks of your specification of your file. What is a specification without tooling? Nothing, right? So why would you want to write a document defining a machine readable document defining how your system interact with each other if you can do nothing with it? Just read it yourself. In this case, you'll probably read it in a human readable way, not machine readable way, right? So so we provide a lot of tools. Of course, we provide something called AsyncAPI Studio, which allows you to create your AsyncAPI files like really in a really easy way, and validates your files on the way, lets you generate via generator, lets you generate the documentation on the fly, generate code. So if you want, from this definition, we're able to generate Node.js code that can subscribe to your MQTT broker or publish message to your MQTT broker, or Java code or .NET code or whatever language, right? We also provide GLI, which is a spec-driven framework. So we use AsyncAPI as the config file of GLI, of the framework. So that means that you'll get the documentation always up to date with your code. So if you don't update your AsyncAPI file, your code will not work, and that makes it possible to have documentation and code always online. And yeah, as a side thing, I will say we provide also GitHub Actions and a parser in different languages, and a bunch of more tooling that I could be listing here, but there's a lot of tooling. I invite you to go to our website, asyncapi.com, and check. Yeah, like I said, we also released a new CLI. So from the CLI, you'll be able to do most of the stuff, and it's very, very handy. So before I forget, we're not a company. It's not my project anymore. So it's not Fran's project anymore. It's a Linux Foundation project right now. So we donated it to Linux Foundation, and now it's an independent project. I work on Postman full-time for the project, but Postman doesn't own the project. And we have other folks in Solas and Adidas and other companies collaborating and in the project as well, right? So yeah, like I said, it's a completely open source and independent project, and not just open source, open governance. I think that's good to mention. So we're getting some traction. As you can see, we've been featured in the InfoQ Software Architecture Trends Report and the ThoughtWorks Technology Radar. And yeah, very briefly, because I'm already getting out of time, it's widely used in production. So you have many big companies and small companies using AsyncAPI nowadays, and I'd recommend you to have a look. I have to give a shout out to our wonderful sponsors, especially Postman, Solas, for dedicating people to work on the project full time, and also the rest, of course, like QBS, Slack, Ably, WSO2, Bump, and Epidec. So yes, if you want to join us, and I encourage you to join us, we're nice people, I promise. Like, we have a super cool Slack workspace where we help everyone with AsyncAPI, and not just AsyncAPI. Actually, we help everyone there, and I encourage you to join and yeah, and participate. Happy to answer any questions, and happy to help. Follow us on Twitter, blah blah blah, right? All this stuff. So yeah, just join us. I think you'll like it, and visit our website, of course, because you have most of the information there. And with that, thanks a lot. You can follow me on Twitter, of course. I talk about lots of stuff, but mainly AsyncAPI, as you can imagine. So thanks.
Well, thank you very much, Fran. Thank you. So a round of applause. I think Tiho actually had a couple of slides that he wanted to prepare to the temporal audience on use cases. Tiho, if you're ready to take like 1 or 2 minutes, just briefly touching upon this, and I'll send people to the full talk that you did at the AsyncAPI Conf as well.
Yeah, definitely.
Trying to share. Take this.
There you go. Yeah. All right. So thank you, Fran. Thanks, everybody. I'll make this really quick. So we learned about AsyncAPI, and I've been involved with kind of their community, and I mean doing some demos around that. I'm sorry I don't have a demo currently for this talk right here, but we're working on a specific demo that we'll share in the Slack channel for you. So just for use cases, as far as temporal users and why AsyncAPI could be important in what you're doing is, Fran already talked about this, so I will not go over it. Basically, you have a YAML definition. He talked about all the different things like the server, the protocol agnostic way of define your server, how to communicate or send events to your servers, and different things like channels, or in case of Kafka, the topics or whatever that you can define via your YAML files on what events you have to send where. You have exact payload and the type of event that you have to set and things like that. In addition, also Fran mentioned the AsyncAPI generators or CLI tools. There is a bunch of them. I just took a screenshot from their website. There's probably a lot more than I missed. But as far as the generators go, from the YAML definition, you can just use these open source CLI generators to generate your whole service, or at least a framework of your service that uses the JSON file, sets you up with the protocols, creates, for example, I'll use the Spring Boot template to set up all the classes that you need to consume and to produce, sets up your configuration, blah, blah, blah. And also it pretty much well aligns with the temporal SDKs. So, we have Node, Java, Python, Go, and probably Fran knows a lot more. So these generators are important. And when you start using them, they help up a lot, going from your YAML definition to an actual implementation of your service that others can consume inside workflows or whatever other applications you might going on. So the generation part goes from the AsyncAPI definitions, or one or more, through the CLI generators, and you can pretty much generate or starting to generate your services, the consume and produce events, and define their interactions. As far as not generating, and this is kind of like most of the use cases, then in our workflows, we have, we all use activities, and our activities in Temporal are really there to communicate with their third-party services. And a lot of times, when we say, okay, write your activity code, and we say, well, your activity code is anything you want to write, we really kind of mean that. And a lot, AsyncAPI can help you, for example, to not have to write a lot of code in your activities. So for example, let's say we have some services that we want to invoke. They are defined via the AsyncAPI definitions. And we can basically, from our workflows and our activities, use this definition to learn about, like Fran said, what URL we have to send the event to, what is the type of message or event we have to send to the payload. And also we know exactly the channel and the protocol that we have to send this message on. So, and also we can really take this AsyncAPI definitions, and especially in our activities, to exactly know what third-party services we have to produce, invoke, and how to invoke them without really having to hard code some stuff, and being able to dynamically update as the AsyncAPI definitions updates as well. So let's just look quickly at 3 use cases. One is, for example, triggering a workflow on event consume. This is a use case where, for example, you have a service that receives, for example, or consumes messages from some protocol, MQTT or Kafka, and on message consumption or event consumption, you want to go ahead and either signal or trigger a workflow, temporal workflow execution. And all this code here on the left is actually generated fully, almost all except the little red box, by the AsyncAPI CLI or the code generators. So it generates this class receive for us. So we don't have to worry how this message is received. And people who send their messages to us know exactly from the AsyncAPI definition how to do it. But once this message is received, we can use the temporal APIs, in this case, the Java API, to create a workflow stub and send this message via Signal to our Signal handler over temporal workflow. So this is one way. I know a lot of people on the forum ask, hey, I have some sort of events that or messages I'm getting from a Kafka topic. How do I actually send them as signals to my temporal workflows? And this could be used there. And just one more, two more quick use cases is one is invoking an event-driven service in activities. So this is a use case where in your activities, you don't want to invoke another service that runs a temporal workflow or a server. For that, temporal actually has the gRPC communication, and our APIs give you everything you need for that. But this is really in case where you, like for example, Checkr invoking some services, they're third party in different counties, internationally or whatever. This can really help you where this is, again, generated code by the AsyncAPI CLI that gives me some sort of transaction event producer, transaction event being defined in our initial definition. And in my activity, instead of writing a whole bunch of boilerplate code, how to connect to Kafka, what hard coding some topics, I can basically just get this producer injected in, let's say, a Spring framework or different languages and different frameworks. And I can just say producer send transaction, and I can communicate with the third-party service without really ever defining in my code or hard coding anything specific about how that communication is actually performed. And the third kind of use case that I have is basically we can consume AsyncAPI definition as a DSL. So for example, in your workflows and especially activities, we can consume one or more definitions or service definitions of AsyncAPI. And these AsyncAPI definitions describe the services that we want to invoke. And even if we don't want to use the CLIs or the code generation part, we can still use this YAML's definition to know exactly how this communication or event-driven communication has to be performed between our workflows and activities and the third-party services that are described by the AsyncAPI definitions. So that's all I had. Thanks a lot. And if you have any questions, either in chat or in our Slack, or we can talk about it there. Thanks a lot.
Yes, and Tiho actually also presented at the AsyncAPI conference. So you can check that out at temporal.io/AsyncAPI. So that's, we're actually running over on our normal meetup time, and a lot of people have to drop for other meetings. But for those people who have time to stay on, we have one more surprise or presentation for you from Steve, who's actually been leading our engineering on the new web UI. We haven't presented publicly about it in a while, so I figured I would get Steve on to demo it. You can actually try it today and talk a little bit about what's next. Steve, are you around?
Hello, yeah. When you try to share
your dulcet
screen,
tones.
Yeah, well, it's usually when you're trying to both share your screen and unmute at the same time, and you do neither particularly well. Cool. Right. So we've got kind of the iteration of the new UI in this case. This is available today, and you can actually run it simultaneously with the existing one as well. And what we aimed for in this initial version was effectively parity, right? Making, when I say parity, like we didn't port every bug over from the initial one, right? Parity with a little bit of quality of life improvements. A lot of what we were going for here was, again, that, the place where we wanted to kind of get to a point where we could iterate for Temporal Cloud and Temporal incredibly quickly, and some of the initial infrastructure that we were bringing over didn't necessarily make that possible, right? So step one was kind of do the kind of clean house and set us up in a place where we can continue to ship relatively quickly. So we've got the workflow list. Looks a little bit different than you might see it in the UI today, as well as some additional filters. One of the really cool things is that you can also then take any of your given settings, share it with your team, and see roughly whatever you were searching for, as well as having the ability to switch over to an advanced query, as you can do today as well. We're actually working through a lot of the kind of the details on kind of reworking some of these pages already based on some customer feedback, but you can kind of like see basically like all the features that you should know and love today are present as we kind of get ready to effectively ship new things every single sprint. Again, kind of crunched on time, so we'll keep it short in this case. So the big questions are how to use it and where do you report bugs and stuff along those lines. Well, that button helps, right? In terms of how to use it, if you just grab the Docker Compose, there's actually an additional setting file here for having that up and running, and then it'll run on 8080 instead of 8088. And then for any kind of feature requests that come along or issues or anything along those lines, right now we're just trying to collect that all in the GitHub issues in this case and kind of have that all in place. So that's the quick PSA. We can kind of do a deeper dive at some future point if anyone and everyone is interested. But in terms of how to use it, it's available in the Docker Compose today. We would love if you would help us kind of suss out any kind of edge cases and stuff along those lines as well, and give us any and all feedback that you might have. Thank you so much.
Short and sweet. Thank you so much, Steve. That was a wonderful update on the state of things. And yeah, and anyone who's interested in better tooling, please follow your feature requests on the repo. So that's it for our meetup. We don't unfortunately have time. We have run over for the last 2 meetups now, so we'll try to keep it consistent. But we meet every month. Sign up on temporal.io/meetup, and otherwise have a wonderful rest of your week. See you when we see you next. See you on Slack, see you on community, wherever. So we'll stick around if anyone has general temporal questions, but otherwise you're free to go. I'm generally trying to stay on a little bit to help people out.